Good afternoon, everyone. Today we are going to discuss the assignment number 4 of dealing with materials data, collection analysis, and interpretation. So, the assignment 4 is more concerned about the statistical part, which includes probability to the most. So, we will discuss one by one. So, first question, in Bernoulli trial, the two random variables that indicate success and failure in a trial are denoted respectively by values. One can be okay, first they are asking success and failure, so it is 1 and 0. So because if one is taken as it's like only two outputs are there for the Bernoulli's trial, success is denoted as 1 and failure is denoted as 0, like binary, yeah, like a binary uh, language, yeah. So a binomial distribution, second question, a binomial distribution consisting of n trials and p as a probability for success can be approximated by Poisson distribution when 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 number of trials tends to infinity, and probability of the particular success is less than, means it's tending to zero in the sense the probability is very less for that to happen. For example, um, uh, like number of accidents in a year. So uh, uh, like a number of accidents in a year in cycle, like that can, the number of accidents is very high, like it will be in lakhs, but the accidents that could be happen because of cycle is very less. In these cases we can use Poisson distribution. And also one more thing is majorly we can use Poisson distribution in the um, industrial site where number of defects which they observe is very less. That is the probability of getting a defect in a number of product. A number of product means it will be close to 2 lakhs or even 3 lakhs, but the defects should be like in ppm, per million parts per million. Defects is expected to happen, because more the number of defects is can ruin their business. So generally the quality of the product is also expressed in sigma, which the deviation from the actual thing is very less, like 6 sigma, like that they use. So number of trials is high and probability of the success is less, means the binomial distribution becomes difficult to evaluate, because n is high, so we can't keep on doing the um, factorial for that, combinations for that particular given variable. So it is better to use Poisson distribution. It will converge to Poisson distribution. Then third question, it is known that each steel slab produced by continuous casting has 5% chance of having inclusion. So probability of having inclusion is 5%, which means 0.05 is the probability. And then if the sampling of slabs is done randomly, what is the probability that out of 100 slabs selected, exactly 4 contains an inclusion? So number of slabs is equal to 100, and they're asking what is the probability of getting 4 defect or 4 inclusions. So as we have discussed in the previous question, like when the number of trials is high, we can use the we can use the Poisson distribution. So n is high and success is very less, it is only 5%. So when n tends to infinity and p tends to 0, Poisson distribution can be used. probability distribution function for the Poisson distribution is given as follows. So where lambda is a Poisson parameter, which is equal to n into p, which is also termed as mean, and x is the probability of x success or x failure, whatever we are using. It's a random variable here. So here they ask exactly 4 containing an inclusion. So we are going to evaluate for x is equal to 4, what is the probability of 4 containing an inclusion. Given the 0.05 is the probability of having an inclusion. So it's just plug in the values, e power minus, so n lambda means it's 5, n lambda is equal to 5, so e power minus 5 into 5 whole power x is 4 divided by x factorial, 4 into 3 into 2. So it gives the answer. Answer should be, okay, let me evaluate. So the answer is 0.178. So this is how we have to calculate. So next, in the above example, what is the probability of 50 slabs are being sampled before the first inclusion is detected? Okay, it's the same problem where p is equal to 0.05. We are asking what is the probability of first inclusion is being detected. So this is closely related to the geometric distribution, where number of trials before first success is followed. So according to the geometric distribution, p of n is x is equal to n is equal to n is the number of trials before first success. So sorry, here n is the first success, and x is equal to 1 minus p is the success probability of success, and q is the probability of failure. So here just have to so 1 minus p means it's q, it's 0.85 into n minus 1, n minus 1 is 49 into 0.05. So if you solve this, you will get an answer close to 0.004. So this is the answer. So next question. So 100 samples were collected from a plant A and 80 samples were collected from plant B. If these samples are mixed together and 5 tests are conducted by drawing samples from the mixed lot with the replacement, what is the probability that exactly 3 samples from a plant A and 2 samples from plant B are selected? Okay, it's like a short problem only. Um, can start by one second. In A is 100, B is 80. So when these two are mixed, probability of getting A, I term a random variable for A as X and random variable for B as Y. Probability of X is equal to 100 by 180 is equal to 5 by 9. P of Y is equal to 80 by 180 is equal to 4 by 9. So this is the probability of getting A from the lot and probability of getting B from the lot. Total means mixed lot. So now what they are asking is like 5 samples are drawn. Five trials or 5 samples are drawn out. In that RA, we take let RA be number of samples from A is 3, number of samples from B is 2. So we can solve this in binomial distribution because we know the number of times is limited and success ratio is success and the failure is not close to 0. They have a very good possibility for this to occur. So let's solve this. So the probability of X is equal to 3, or means or RA here given here is equal to RA or X is equal to 3 is given by N is 5, C 3. It's like same formula NCR to P power N Q power N minus 1. This P is 5 by 9 for the first case, drawing A ball, sorry, A sample from A from drawing sample from plant A. The N is 5. Sorry, P power R Q power N minus R. I did a mistake here, sorry. P power R. R is 3. Q is 4 by 9, which is 1 by P. Okay, so this is for the case 1, which is like drawing sample from plant A. Similarly, let's evaluate the answer later. Similarly, drawing the sample from plant B, which is number of samples is 2 from the plant B, is given by the same equation 5C2. Yeah, here the success is 4 by 9. 4 by 9 whole power um, N R is 2, and then Q is 5 by 9. 5 by 9 whole power N minus R. N is 5 and R is 2, so N minus R is 3. So let's keep it as it. So what we are going to do now is they are asking 3 samples from plant A and 2 samples from plant B exactly, and this has to happen simultaneously. So in this case, so it is like P of X intersection P of B, sorry, P of Y. So since for this to, since they are independent variables, we can multiply them. So we have to multiply these two probability. So here it is 0.338. Since all are same here, so it is also 0.338. So the answer we got is, 1 second, 0.11. So but it is not matching with the given answer. So but answer whatever we have got is 0.1. So this I will discuss with TA or course TA or with the professor and let you know. But this is the way to solve this problem. So let's go to question number 6. So in this, the probability of a getting number by rotating the roulette wheel has dash discrete distribution. Okay, so it is a discrete distribution. So these two options are ruled out because log normal and normal or continuous distribution, they are not normal discrete distribution. So it should be either uniform or Poisson. So here in this case, this wheel has several numbers and they all have equal chance of getting equal chance of getting. So here Poisson distribution cannot be used because as we know, for Poisson distribution the success rate should be less, failure rate is high, so it is not uniformly distributed. So it's not Poisson distribution as well, it's uniform distribution. So let's go to the 7th question. So 7th question is, check whether the following statement is true or false. Okay, if x is a binomial random variable with parameter n and p such that n is higher than p, so this is a standard normal variable. So what they're asking is like, if you want to derive um, yeah, new random variable, um, since if n is higher than p, then binomial distribution is invalid, means it will become tedious to calculate because as we know the calculation has become tedious. So when n is very high, then standard normal variable, so this is, they are reducing the binomial distribution to a normal distribution. So when it can happen is, how they are doing it. So as you all know, standard normal distribution has mean is equal to 0, so it will mean is at the center. So mean is equal to 0, and here the standard deviation is divided or normalized. That is what normal distribution is, normalized to 1. So this is one standard deviation, sigma is equal to 1, sigma is equal to 2. Since it is divided, so it will be like a normalized value. It won't have any um, significant values, like it is it's between 1 2 3 like that will go. So when if you want to do this, like you have to divide, you have to first subtract the mean, so that you are bringing the curve to the center, and so you are bringing this distribution to the center. So that is what they have done here. Yeah, as you all know, mean is equal to n into p in binomial distribution, and npq is equal to variance in binomial distribution, and standard deviation is equal to root of npq. So they have subtracted the mean to bring to the center and divided by divided the whole range with the standard deviation, and so they have normalized. So that is a standard normal variate. So if you ask like whether this is true, yes, it is true. Let's go to the eighth question. So eighth question, if a probability density function of a measurement of a particular material property is given by, okay, they have given the probability density function PDF f of x is equal to 2 by 3 in a given interval 3.5 to x to 5. Otherwise, f of x is equal to 0. So they are asking what is the probability that measured value is between 3.9 and 4.1. So probability of a function given by in a given interval f of x dx. Here the interval is from 3.9 to 4.1. So 3.9 to 4.1 into 2 by 3 dx. So we will get 2 by 3. If we integrate, we will get x. Integration of dx is x, and then 3.9 to 4.1. So when you subtract this, you will get 0.2 into 2 by 3. I mean, like when you plug in the upper and lower limit, and if you get subtract it, you will get the following. So it's 0.4 divided by 3 should be close to 0.13. So this is the answer. Okay, let's go to the ninth question. So in ninth question, in normal distribution, mu plus 3 sigma covers dash percent of all data. Okay, this can be calculated using Taylor's function, and it's a tedious process. So the thumb rule or the empirical rule is 1 sigma covers 68.26% of the data, which means 1 standard deviation. That 2 times the standard deviation covers like almost 95.444% data, and 3 sigma, whatever they have asked here, right, plus or minus 3 sigma covers 99.73% of the values or range. So that's all. So 10th question, the number of times an ATM is used in a day follows an exponential distribution. Okay, so time usage interval is an exponential distribution. If an ATM is used by an average of 20 people per hour, what is the probability that equipment is unused for interval of 10 minutes any time of the day? Okay, the time interval is an exponential distribution, so Poisson distribution can be used to solve this problem. So average use in minutes, I mean per minute, is given by P is equal to 20 by 60 is equal to 1 by 3 people per minute. So number of minutes a sample is not being in usage is equal to 10 minutes. So Poisson parameter is n into p, sorry, n number of minutes is n into p is equal to 10 by 3, that is 1 by 3 into 10, so it's 10 by 3. So probability of x is here we have to choose wisely. So x is like usage. So when you want to find for um, unused means not in use, means you have to make p of x is equal to 0. If x is equal to 0 is given by e power minus what is lambda, it is 10 by 3 into lambda is 10 by 3 whole power 0 factor is equal to 1. This also equal to 1. So it will reduce to e power minus 10 by 3, 0.035 is the answer. So, okay, let's go to the 11th question. It's a final question. Which of the following continuous distribution function has a memoryless property? Likelihood of happening something in the future is independent. Okay. So when you see all the other distribution, they have um, the memory, like they take all the data range. But if you take the memory, if you take the exponential distribution, they follow this. The probability of x greater than s plus t, that which is x is greater than s, is equal to probability of x is greater than t, which means like if you have a timeline like this, so this is yes, so something would have happened after time t. So to find the probability of uh, that s from s to t, um, we don't take any past data. Means exponential distribution function doesn't take any past data. Instead, it will just give x greater than t, probability of x greater than t, and that gives the answer for the total problem. It is like probability of x greater than of x s plus t. So how this is related to the current world? So this can be expressed with an example. 1 second. Generally, if x represents the lifetime of or x represents the creep rupture life of a material. So like say it is not creep rupture life, I would say like epsilon t. So if suppose you are in this point, say it is x, so you want to know what okay, this is x, you are in the point x and you want to know what is the probability of failure at time x plus t. So what this function does is this function doesn't take what happened before x into account. It will only see from the x. So it forgets the memory of the previous data and just go with the current one. So probability of the life having x plus t is nothing but probability of x greater than t. So if we find this, then we are indirectly getting the probability of the total lifetime. That is like before rupture we are getting. So this is the advantage of this exponential distribution function. So for estimating the means lifetime. So for these applications we can use the exponential distribution function. So with this we have completed all the 11 problems. So this problem alone I have to check and give the answer. Apart from that, other answers whatever we discussed are in line with the and solutions provided by the professor. So yeah, okay. So if you have any further doubt, please let me know. This is my mail ID mm19d754 at ismail.it.ac.in. So you can write a mail to this. like I can provide solution or doubt clearing session um, whenever it is required and whenever it is possible. So in case if you have missed this live session, thank you.